Hello and welcome. Up to this point, we have talked about how to find derivatives of individual functions, but we haven't talked about what happens or how to find the derivative if we have the product of two functions. What I mean by that is we have talked about how to find the derivative of something like x cubed plus sine of x, and how that derivative would become 3x squared using the power rule, and plus cosine of x using the fact that the derivative of sine is cosine. But we haven't talked about what would happen if we were actually trying to find the derivative of the product of those two functions together instead of the sum as we just did. And that's what this video is about. How do we find the derivative when what we're looking at is the product of two functions? What is the rule for doing that? And the name of this rule is the product rule. The basic idea behind what the product rule says is that if we have two separate functions, we're going to take the derivative of one function and multiply it by the original other function. And we're going to add that to the original first function times the derivative of the second. So remember that we are at some point taking the derivative of each of the two functions that are being multiplied together and multiplying that derivative by the original other function. So let's look at this. Let's actually look at the example that I had just erased that we were talking about, x cubed times sine of x. So here is one function, x to the third, and here is the second function, sine of x, and I'm multiplying these two things together. So when I find the derivative, I'm going to take the derivative of this blue function, which we know to be 3x squared, and I'm going to multiply that by the original second function that's there. I'm going to add that with my original first function, x to the third, times the derivative of that second function, cosine of x. And this gives me my derivative using the product rule. So something that's really helpful, especially if you have multiple colors, is to identify your two separate functions. So I'm going to look at this example on the right. I'm going to call this first part my blue function and the second part my red function. So when I am finding the derivative, I'm going to find the derivative first of the blue function, which using the power rule is just going to be 6x. I'm going to multiply that by the second function, not its derivative, just the second function. And I'm going to add the original blue function, 3x squared minus 2, multiplied by the derivative of the red function, which is 2. And then I'm going to simplify this by just cleaning it up a little bit and multiplying it out. And then again by combining like terms. So here is my simplified derivative. Now, something I want you to notice, and we're going to kind of confirm that what we just did actually makes sense, is that even though this is a product up here, this original function, we could use algebra to expand that out and rewrite it just as a polynomial, right? We can just multiply that out, which would give us 6x to the third power. If I multiply here, 9x squared minus 4x minus 6. And now we can use what we used earlier in this chapter and actually just take the derivative using the power rule. So this would become 18x squared. This would become 18x. And this would become minus 4. And we can see that these two derivatives match. So just because we're learning the power rule, just because we're learning the product rule doesn't mean that the things that we have learned before don't apply. But this is another way, if we have a product, and oftentimes we won't be able to simplify into a polynomial the way we just did, how we can find the derivative using the product rule. Let's look at some more examples. Okay, so on number 1, I'm going to identify my two functions. Here's my first function being multiplied by my second function. So f prime of x is going to equal the derivative of the first. The derivative of x squared is 2x. I'm going to keep cosine x exactly the same. And I'm going to add the original function, which is x squared, times the derivative of cosine of x, which is negative sine of x. And I'm going to just rewrite this so that I don't have that subtraction sign sort of in a weird place. 2x cosine of x minus x squared sine of x. Okay, looking at number 2, I'm going to rewrite this using rational exponents instead of radicals. So remember that the cube root of x squared, the top number of the fraction is the number that's inside. I like to say top dog in the doghouse. So it's going to be 2 over 3, x to the 2 over 3 times x cubed minus 1. I also want to point out on this problem, you don't necessarily have to use the product rule. You could multiply and expand this out and then just use the power rule. But since we're practicing the product rule, let's go ahead and do it that way in this part. So here is our first function, and here is our second function. So f prime of x is going to equal, if I drop the exponent down, 2/3 times x to the power of negative 1/3, since 2/3 minus 1 is negative 1/3, times the second function, plus the original function, x to the power of 2/3, times the derivative of our red function, which is 3x squared. And I'm going to be pretty lenient. I don't need you to simplify this too much. If it helps you to do so, you can. But really, I want to see that you are correctly finding the derivative using the product rule. On number 3, your first thought might be, we don't actually have a product here. We have a quotient. I have sine of x over the square root of x. But what I want you to think about is there a way for you to rewrite that denominator so instead of having a fraction, we have a product? So pause the video and see if you can think of a way to rewrite that. Okay, so hopefully you had time to realize that if I have x to the 1/2, or the square root of x in the denominator, that's really the same thing as x to the power of negative 1/2, and now we have a product. In the next video, we're actually going to talk about how to differentiate this using the fact that it is a quotient. But now that we've rewritten it, we can find the derivative. So I encourage you to pause the video and work through 3 and 4 on your own, and then unpause the video and see how you did. So here's my first function, and here's my second function. So f prime of x is going to equal the derivative of sine is cosine. Keep your second function the same, plus sine of x times the derivative of my red function, which is negative 1/2. Negative 1/2 minus 1 is going to be negative 3/2. And I'm going to clean this up just a little bit. And I'm going to put my x terms in the front so it doesn't get confusing with my sine and cosines. And there we have it. Again, for number 4, you could expand this out and find the derivative of the polynomial, but I'm going to practice using the power rule here, using the product rule here. If I take the derivative of the red term, I get 2x plus 4 times the blue term, x cubed plus 1, plus, keep the first term the same, and I'm running out of room, so I'm going to come down here, x squared plus 4x minus 5, times the derivative of the blue term, which is 3x squared. Again, for now, I'm okay with you stopping right here and not actually multiplying all of this out. That's the algebra part. The calculus part is being able to find the derivative using the power rule. Let's go ahead and look at 2 last examples, extending this idea of using the power rule to the idea of finding a tangent line. So looking at number 6 here, find the equation of the tangent line through the given point. So remember, when they give us a point, we can immediately start by filling in what we know is going to be true for point slope form. In order to write the equation of a line, we need a slope and a point. We have a point, so all that we have left to find is our slope, and the derivative is the slope. So if I take the derivative of this purple function, I just get 1 times the red function, not its derivative, just the way it is, plus the purple function times the derivative of the red function. And now I only care, I don't need to simplify this at all, I only care about this function when x is the x value in this ordered pair. So I actually want to figure out what f prime of 3 is. So I'm going to plug 3 in anywhere that there's an x, and then I'm going to simplify. 3 and 3. So here, 3 squared is 9, minus 5 is 4, 3 plus 2 is 5, times 6 is 30. So this slope is going to be 34, and that's going to go in the slope spot of point slope form right there. Go ahead and try number 7 on your own. So here we have the derivative function. I'm really excited because I care about this derivative when x is 0, which means a lot of things are going to become 0. This is going to become 0 plus 2, so just 2. This is also going to become 0 plus 2. And then this is 0 plus 0 minus 4, so negative 4 times 0. So all of that work just to get down to our slope being 4, and our slope goes in the slope part of this point slope equation of a line. And you could write that without the minus 0 as well. To wrap up, before we sort of do a short recap of what we covered in this video, I want to look at a more abstract problem where we don't actually have functions defined explicitly. So here we know a couple of things. We know that f of 2 is 3. We know that f prime of 2 is negative 1, and we're being told that we have some other function g that is defined to be x squared times f of x, and we're being asked to find g of 2. So let's just look at the function g first. G of x is x squared times f of x, and we're going to apply the product rule because I'm multiplying x squared by f of x. So here's my first function, here's my second function. Let's just apply the power rule, the product rule. The derivative of x squared is 2x. We're going to multiply that by f of x. We're going to add x squared. And the derivative of f of x, we're just going to write as f prime of x. Now we're going to plug in what we know. We know that what we're looking for is g prime of 2. So we're going to plug 2 in anywhere that there is an x times f prime of 2. And then let's go ahead and simplify this. G prime of 2 is going to be 4 times f of 2, and we know that f of 2 is 3, plus 4 times f prime of 2, which over here f prime of 2 is negative 1. So this is going to be 12 minus 4, so g prime of 2 is 8. So even when we get a problem that looks more complicated or more abstract, just work through what you know. Apply the product rule, plug in what you know, and use any other information in the problem to help you get to a final value. So the focus of this video, what is the product rule and how do we use it? We recapped using some sine and cosine derivatives. We talked about how you can rewrite oftentimes a quotient as a product using negative exponents, and also how sometimes when a problem looks like it needs to use the product rule, you could really multiply it out and use the power rule instead. We then reviewed equations of tangent lines and how to find the derivative in a more abstract situation. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.